Hey everyone, welcome. Today, we're going to break down one of the most fundamental ideas in math, relations and functions. And trust me, by the end of this, you're going to see them everywhere.
All right, let's kick things off with a bit of a puzzle. What in the world could your favorite food and your height possibly have in common? I know it sounds pretty random, right? But mathematically, they can both be part of something we call a relation. So, first things first, what even is a relation? Well, at its core, it's just a way to describe how different bits of data are connected. Okay, in math speak, a relation is really just any set of ordered pairs. That's it. It's just a fancy way to link two pieces of info together where, and this is key, the order really matters. Take a look at this. We've got a list of names, and right next to them, their favorite things to do on vacation. This table, it's a perfect real-world example of a mathematical relation. It's just connecting one set of info, the names, to another set of info, the activities. And what we can do is take that table and turn it into a set of these ordered pairs. Now, the most important thing here is the order. The name always comes first, then the activity. This means the pair, say Alicia reading, is totally different from reading Alicia. Okay, so we've got these ordered pairs. Each part of that pair actually has a special mathematical name, the domain and the range. Let's break down what those mean, because it's super simple.
First up, the domain. The domain is just all the possible first things in our ordered pairs. A really great way to think about it is that the domain is your list of inputs.
So, going back to our vacation example, that whole list of names, Alicia, Davina, Zhang, Alonzo, and Dwayne, that is our domain. It's the complete set of all our inputs. And you guessed it, if the domain is the input, then the range is the other half. It's the set of all the second items in the pairs. We call these the outputs. So right here, the favorite activities, reading, camping, skiing, and hiking, that's our range. This is the set of all the possible outputs for this particular relation.
All right, now this is where things get really cool. See, not all relations are created equal. Some of them are extra special. They follow one very specific, very important rule, and we call these functions.
Okay, if you remember one thing today, let it be this. For a relation to officially be a function, every single input has to be paired with one and only one output. I'll say it again, one input, one output, no exceptions.
You know, the easiest way to picture this is to think of a vending machine. When you press button B4, you're expecting to get chips, right? And only chips. Imagine if you pressed B4 and sometimes you got chips, but other times you got a soda. That machine would be broken. It wouldn't be functioning properly.
This slide really shows that rule in action. On the left, see how that one input, reading, has lines going to multiple outputs? That is not a function. But look at the right side. Each input, like Alicia, has exactly one line going to one output. That's what makes it a function. See the difference? All right, time to put on our detective hats and be function inspectors. We're going to look at a new relation from our data, and our job is to decide if it follows that super strict one-output rule. Okay, let's try a new one. What if we make a relation by pairing each person's height with their weight? So height is our input and weight is our output. Think about it. Would this relation be a function? Take a close look at the data here. Scan down that height column. That's our set of inputs. Do you spot anything a little weird about the input 70 inches? And there it is. This relation is not a function. And why? Because that single input, 70 inches, is paired with two different outputs, 148 pounds and 166 pounds. That breaks our one and only one rule big time.
Okay, I think you've got the concepts down, so now it's time to really put your new skills to the test. Let's do a couple of quick examples, straight from your lesson.
Okay, first one, look at this diagram. Remember, the items on the left side, that's our domain, our inputs. The question is, does each one of those inputs have exactly one line pointing to something in the range?
Go ahead and pause if you need to. Take a second, look at it, and decide, function or not a function?
If you said yes, you are absolutely correct. It is a function. Every single input on the left has exactly one arrow pointing away from it to an output on the right. It follows the rule perfectly.
Nice work. Okay, let's try one more. Analyze this diagram carefully. Scan those inputs on the left again. What do you see this time? Aha, this one is not a function. And the reason is right there. See that one input that has two arrows pointing to two different outputs? The second you spot an input with more than one output, you know the rule's been broken. It's not a function.
So let's just wrap up the big idea here. All functions are relations, but, and this is a big but, not all relations get to be functions. The only relations that get that special title are the ones that follow that strict rule. Every single input has to have exactly one output. You know, this rule is what makes them so powerful. It lets us predict outcomes, which is really the foundation of, well, everything from science to computer programming. And as a final thought, I want you to start looking for this stuff. Now that you know the rule, where else do you see functions kind of hiding in your daily life? I mean, think about it. Your phone's contact list, right? One name gives you one number. Or a GPS, where one address gives you one location on a map. How many of these hidden functions are you using, like, every single day?